we are looking at identifying congruent triangles. Congruent triangles are triangles with 3 congruent sides and 3 congruent angles, meaning you're comparing 2 different triangles for them to be congruent. Corresponding parts are sides or angles that are in the same location and have the same position. They have to line up, but are on different triangles. So in this picture you can see this is called a congruency statement in this little box here. Triangle ABC is congruent to triangle DEF. It doesn't matter how the first one is written, it just matters that the second one, these parts need to match up with the original one here. So like the A would match up to the D. If I look at the picture, A has 1 congruent mark and D has 1 congruent mark. So this is called a congruency statement, and it tells me a lot about the picture even if I don't have the picture. Whichever letter is first, A, corresponds to the first letter of the other triangle, D. So if you want to say segment AB, if I didn't have this picture to see the little 1 mark here and a 1 mark here, we could say AB would be congruent to DE, the other first 2 letters in the statement. This one happens to have things to match. You can see 1 congruent mark should match up with 1 congruent mark. So let's go to the next one. BC should match up with EF. So we're trying to find pairs of segments that are equal. This one says AC should match up with DF. Alright, now I have angle A, just individually. Angle A has 1 mark, so that matches angle D has 1 mark. Angle B has 2 marks, so angle E has 2 marks. And C would match up with angle F. So matching what's called corresponding parts is when you have one angle in one triangle should match up with another angle in the other triangle if they're congruent. Alright, CPCTC stands for corresponding parts of congruent triangles are congruent. So same thing we did here, only they didn't give you blanks to fill in. They're wanting you to look at this picture now and write down, based on this statement, which segments are congruent and which angles are congruent. So if we start with segments like they did here, so you just take the first 2 letters. AB is congruent to DE. Next 2 letters, BC would be congruent to EF. And the first and last, AC would be congruent to DF. This is not well planned out because we have the exact same letters in this example as you do on this example. So I bet, even though the triangles look different, you can match up the letters. Like for instance, letter A should match letter D. So angle A is congruent to angle D. The second letter C is angle B would be congruent to the other second letter, which is angle E. And angle C is congruent to angle F. So this is a congruency statement, and these would be what's called the corresponding parts that match up within those triangles. Alright, now it's your turn. Here is a picture, and here is a statement. I always like to refer back to the statement because they can rotate, they can reflect, they can do lots of things with the shape to kind of confuse you, but if they give you the statement, you know what's in order in the statement will always be match up. So for instance, it says BN, so segment BN, those are the first 2 letters here, so these are the first 2 letters there. The reason they lost the line above it to show a segment is because these were all congruent signs, and we write segment symbols with equal signs, we just write the letters. So, if you haven't, go ahead and try these on your own and then check your work. Maybe pause the video. I'm going to go ahead and continue. So I have TW would be equal to FN. The first and last BF is equal equal to ST. Then it just specifically wants angles. This would be angle W would be equal to angle, the second one, so N. B is the first one, so that should equal angle S. And the last one, angle F, would equal angle T. Okay, so these are called corresponding parts. Sides are angles that are equal because the triangles are equal. Okay, the next thing we're going to talk about, incongruent angles. There are some assumptions that can be made. These are a couple of those assumptions. It says parallel lines create congruent angles. These are angles that we talked about in Unit 1B, alternate interior, alternate exterior, and corresponding. These angles are formed because you see these arrows on the lines. That means those are parallel. So if those are parallel, we can say certain angles are congruent. I don't really have any corresponding here, but if you extend these lines, this angle is equal to this angle. So we could say angle D is congruent to angle E because they are both touching the same line. This is called a transversal that hits those parallel lines. This one's unique because it has two sets of these. We could also mark this angle is congruent to this angle. Those are also called alternate interior angles. So I'm just going to make a note here, alternate interior angles. Okay? Like I said, corresponding I didn't have in that picture. Another one we learned in the beginning of the year, these are called vertical angles. Vertical angles are when two lines intersect and it creates these congruent angles. Okay? So you could say angle, let's do ACB is congruent to angle ECD. Okay, if I start with A and went A to C, it has 2 marks. So I did E to C because it had 2 marks. Alright, another thing you can mark in a picture, these were all related to angles, okay? So either alternate interior angles, corresponding angles, vertical angles, these are all angles. There are some times that certain sides can be marked. It says congruent triangle parts can be proven from common sides. If they share a side, these two triangles here meet at side DB, we can automatically mark that that side is congruent to itself. So BD is congruent to BD. And we call that the reflexive property. If they share a side, that's called the reflexive property because it's always equal to itself. So in this example, we want to mark the congruent sides or angles on the figure. Use symbols and explain your reasoning. So for instance, the only side we're going to mark that if it's not already marked would be if the two triangles are connected by a side. So these triangles aren't connected by a side, so I'm going to be looking for angles. I don't have any parallel lines, so I can't check anything off that box, but it does kind of look like this picture. So what I'm looking for is vertical angles. So we're going to put this is congruent to that. So we're going to say angle, don't really know enough here, but we could say angle BCA is congruent to angle ECD. And my reason, I'm going to write vertical angles. Okay, the next picture I have quite a few things that we can mark. We not only have our vertical angles, so I can still put those down. So I'll just write again vertical. But this one, you'll see these arrows. Remember, arrows mean parallel lines. So I could also mark these angles. And see if you remember what those kind of angles are called. I'm just going to say angle B is congruent to angle E by alternate interior angles. And the same thing can go the other way. Angle A is congruent to angle D. That's not an angle sign. Alright, this one doesn't have vertical angles. We don't have any parallel lines. So the only thing we do have in this picture is what we call a common side. This side that they share, both triangles have that same side in the middle. So we're going to say HF is congruent to HF. And we're going to say reflexive. That's called the reflexive property. If it's equal to itself, they share a common side. Alright, so take a minute. See if you can figure out anything else. Actually, these are kind of tricky. Maybe we'll do them together. This particular picture, if you remember that these lines on the side means this is an isosceles triangle. And we learned a theorem last class. In an isosceles triangle, if those two sides are equal, these are called the legs, and this is called the base. If those two sides are equal, then we can mark that the base angles are equal. I'm going to say angle L is congruent to angle N. This doesn't really pertain to congruent triangles because there was only one triangle in the picture, but that is an example of something you could mark. The next one has some arrows on it. Remember, arrows means parallel lines. So since we have parallel lines, we have corresponding angles. This angle is corresponding. If this was our parallel line, those spots are in the same position. I'm going to say angle RQS is congruent to angle TSU. We'll also notice we have another set of parallel lines, so we also have another set of corresponding angles. So RSQ is going to correspond to angle TUS. Alright, we got one more here. We have no parallel lines, we have no vertical angles, so the only thing we have is they share a side. If they're connected by a side, that's called reflexive property. XY is congruent to XY. They share the exact same side, and so it should be equal to itself. That is an update on congruent triangles. Special things we can mark. We can mark if the lines are parallel, you have arrows, you have these things you can mark. These are vertical angles. Okay, vertical angles can also be sideways, like I could do this. The reason I didn't mark that earlier is because it wasn't inside the triangle, and we're talking about triangles a lot. And then the common side, if they share a side, that's an example of what we call reflexive property. So if they have a common side, that's something that you can mark.